All right, welcome. Another exciting episode. Today is Friday. Thank God it's Friday, March the 7th, the end of the third 9 weeks. Seniors, you are just entering into your last 9 weeks of high school, okay? And it's a shortened 9 weeks because we're only kind of going to the beginning of May. So you are March and April away from being high school graduates. Okay, you're March and April away from making a 5 on the AP Chemistry exam. Okay. All right, so, hey, we're in the final stretch. But y'all, let me just give you this, my little motivational speech. Okay, because a champion is running a race. And when the champion is going and they're getting into that final lap, the average person starts feeling the pain, starts feeling the hurt, starts feeling the cramps. And so they tend to start fading, you know, that even though they started out the gate strong. But the champion, when you look at the champions on the football team, what do? Fourth quarter, they raise up their hand because that's when the match is, that's when the game is won. Fourth quarter. A sprinter, a distance runner always has that last little bit of kick at the end. They don't coast into the finish line. I've watched it when I was coaching tennis and they'd have the track meets and I'd see this person out front, but on the last lap, they were just fading. And then the champion was coming around and they had that little bit of extra kick that they had prepared for and they kicked it in and they passed that person coming into the final lap and they ended up winning the prize. So we don't quit coming in, we don't coast coming into the fourth quarter, into this fourth 9 weeks. This is where we kick it in. This is where we had that little extra and we work a little bit harder and we review and we get stronger and we finish strong. Then we can celebrate with the prize, which is our good grade. All right, so we ready to go? All right, we got 2 units left, electrochemistry and acids and bases. And we're gonna finish strong and then we're gonna celebrate in May. Here we go. So when I look at 26A, all right, so let's just talk about how we can do 26A. So we're at NO2 minus plus Cr2O7, 2 minus, going to Cr3 plus. And y'all, just so you know, up until like 2005 or 6, somewhere in that range, there's a whole section on the AP test where you had to know what these ionic equations made. So something like this, you would always have to know that Cr2O7, 2 minus, always would go to Cr3 plus. You would have to memorize a whole slew of ionic equations, what would happen, okay? It was 8, they gave you 8 equations, you had to fill in 5 of them, and you would just have to know what the products were, and there was a lot of memorization on that. Thank God they got rid of that part. Okay? Plus NO3 minus. So we're kind of, in one sense, we like that new format that we don't have to memorize these equations. Because that's really the only way to know it, is memorize. Okay, so can we do our oxidations? Tell me, just take 2 minutes, determine which substance is being oxidized, which substance is being reduced. Getting fired up. Happy. Only my second one for the day. The big top, yeah. Okay. So when we're looking here then, so what is the oxidation state of nitrogen here? Okay, it's +3. What is it here? +5. I'm hesitant to ask the question. Is it oxidized or is it reduced, Carter?
It's being reduced.
I told you.
Did the charge go up or down?
It's being
The charge went up.
You were
Okay. Y'all, the whole point, the term reduction means the charge is being reduced. That's all you have to remember. Oxidation is the other one. Okay?
Oh, and lost.
It does. Don't try to do lose and gain because you guys can't handle the negative numbers. Look at the charge. Reduction means the charge went down. It was reduced. Oxidation is the other one. Okay? Graham crackers. I'm the one that needs them because I'm having some evil thoughts right now. So,
It's so over.
it's oxidized.
You actually gotta like
Okay? Now, here we go. Obviously, the other one then is reduced. Okay? But the chromium, what's its oxidation state here? Plus 6. Okay? And it's plus 3 here. So it's being reduced. Okay? So it's going from plus 6 to plus 3. Now, we're going to break it up into our two half reactions. What's our first half reaction? NO2 minus. Okay, Saman, keep going. Goes to NO3 minus. Okay? So how do are the nitrogens balanced? Yeah. How do I balance oxygens? Okay, so I put a water over here. Now that gives me 2 H pluses. So I need 2 H pluses here. Okay? Now here's the next tricky question. to which side and how many negative electrons do I need to add? How many electrons to which side to make the two sides equal?
2 on the right.
2 on the right, because we got 2 minuses, minus and a minus, so I just got to balance this one out, plus 2 electrons. Okay? Because now it's minus 1 on the left, minus 1 on the right. So now my other half reaction is what? Cr2O7 going to Cr3 plus.
We got it balanced.
So what's the first thing I need to do?
Balance the CR.
Balance the CRs. So I put a 2. Right? So now I got 7 oxygens, so I need 7 H2Os. Now, again, this one is going to be exactly the same as, I think it was the first one that we did in 25A, the Cr2O7, because the half reaction doesn't change. Cr2O7 going to Cr3 plus, the half reaction is going to end up being exactly the same as it was in 25A. So we have 7 waters. Now what do I need to put over here? 14 H pluses. Okay, so what's the total charge now on the left?
Plus 12.
Plus 12. What's the total charge on the right? Plus 6. Okay, so to which side and how many do I need to add electrons to make the two sides balance? 6 on the left. Okay. Now both half reactions are balanced in reference to themselves in both charge and now let's just put it in the middle of my desk, Michael. Okay? Do I need to send an email or anything to anybody?
No.
Okay. Now, what's the next step? Why, Drew?
Because you have 3 times as many electrons than your redox, so you need to make the electrons equal.
Okay, the key thing is electrons gained has to equal electrons lost. Electrons gained have to equal electrons lost. So we multiply one or both of the equations to get a common multiple. In this case, we can just multiply this one by 3. Okay? And we're going to end up getting 3, 3, 3, 6, and 6. Now, we're going to add them together. But the one thing that must cancel out completely are your electrons. Electrons gained must equal electrons lost. Waters and everything else can be, not balanced, not even. But I have 3 waters on the left, 7 waters on the right. So I net out
4 on the right.
4 on the right. Okay. And I have, what I 14 H pluses and 6 H pluses. So I'm going to end up at 8 H pluses. So I'm going to go 8 H plus 3 NO2 minus plus Cr2O7 2 minus goes to 3 NO3 minus plus 2 2 Cr3 pluses plus 4 H2Os. So then I have my balanced reaction, my two half reactions. So the top one, is that top one my oxidation or reduction reaction? This top one, is this the oxidation or reduction half?
Oxidation.
Oxidation, the electrons are on the left, they got lost. This is my oxidation half, this is my reduction half.
Will there ever be a rare case where we have to do a basic solution?
The only thing that's different is instead of adding H pluses to do the hydrogens, you do OH minuses. Now the reason why it's more challenging is because you have oxygens and hydrogens in both. Okay? So I might do one just to show, but I'm not going to spend a lot of time on it because I haven't, like I said, I haven't seen one in a base in a long time.
And will it won't be on your test?
Maybe like as a bonus after I do one. Just like the last time I said a bonus and I forgot to do the bonus problem. Okay? All right, so I'm just gonna let us do one more and I'm gonna let you guys do one and then we're gonna move on. So let's pick, let me look at one. God, they like that one. Okay, just do B, 26B. B. Let's see how that one works.
Like ourselves.
Yes.
If a solid and gap.
Doesn't matter. State doesn't matter. All right, here we go. So let's look at this. So obviously, what's the oxidation state of any element in its natural state?
0.
0. So I know right off the bat, 0 going to something is going to be, this is a redox reaction. Okay? So a multiple choice question, you know, is this a redox reaction? You know, if it starts at 0 and ends up in a compound somehow, yes. Because if one thing's oxidized or reduced, something else is the opposite. Okay? So I know sulfur is going from 0 to what is it here? And anybody want to venture a guess as to the name of that compound? No.
Dihydrogen.
If the hydrogen's the first thing, what type of compound is it? It's an acid. Sulfuric acid would come from the sulfate ion.
Sulfite acid. Sulfate acid. Sulfuric acid.
No, not sulfuric. Sulfuric is H2SO4. Eight goes,
Nitrate.
hey, 8 goes to ick. I goes to
It's nitric acid. Nitrate.
nitric with no, there's no nitrogen in
Wait,
here.
which one are we looking
This
at?
one,
Sulfurous.
the underlined one.
Sulfurous.
Say that again.
Sulfurous.
Sulfurous.
Why did you just yell? I'm going back to leave.
Yeah. Sulfurous acid. Now you don't have to name those, but that's just a little flashback. Okay, so now what's the oxidation state of sulfur in sulfurous acid? +4. Does everybody understand how to get +4?
Wait, quarter, how do we get in +4?
Oh, because so your total is +2,
Okay?
and then your O's total is -6.
Okay.
So you need a +4.
Has to equal 0. All right? Now, what's the nitrogen here? +5. And this is kind of a crazy one here, but what's the nitrogen here? +1. Okay, so I made you another nice easy one here. So again, just looking here, is it being oxidized or reduced? Oxidized. Okay, Carter's staying quiet. Okay, and that makes the nitrogen, meaning it's reduced. Okay, now the half reaction, I'm going to go sulfur going to H2SO3. So I'm always going to want to balance my oxygens first. So I'm going to put 3 waters over here. Now that gives me 6 hydrogens. I have 2. So I only need 4 more over here. Okay? Now I have 0 on the left, but I have plus 4 on the right. So I got to put 4 electrons over here. So we already know that this is my oxidation half, but always in the oxidation, the electrons are going to be on the right-hand side because you're separating. They're losing electrons. So now we go HNO3 going to N2O. Now, so what's the first thing I have to do?
Balance the ends.
Balance the ends. I have to put a 2 there. Okay? That if you don't do that, that's going to mess everything else up because that changes my number of oxygens. So I have 6 oxygens. I have 1 oxygen. So I need to put 5 waters over here. Okay? So 5 waters. Now that gives me 10 hydrogens. I have 2. So I put 8 over here. Now I have 0 on the right. So I have to put what on the left? 8 electrons over here on the left.
What's up to?
Okay, so then I multiply the top one by 2
Wait, why do we do that to get the same?
because I have to make electrons gained equal electrons lost. So I'm going to end up getting 6, 2, 2, 8, and 8. Now I add them together, and once again my electrons must cancel out completely. So I'm left with 6 waters and 5 waters. So I'm going to be left with 1 water over here, 8 H pluses and 8 H pluses all cancel out. So I'm going to be left with a water plus 2S plus 2HNO3, nitric acid, goes to 2H2SO3 plus N2O. Okay?
I did it.
All right.
Wait, do you need to put like the states, like solids,
No.
aqueous?
Okay. Most of the time on this is going to be in what do we call it? Multiple choice.
So,
They'll just really have you filling in the coefficients.
so for when we're looking at oxidation or reduction, do we not care about if the oxygen or hydrogens get oxidized or reduced? Because
They're generally not going to.
okay.
Oxygens and hydrogen very rarely.
So in the original equation that we gave, the nitrogens aren't balanced. Did you be careful with that or no?
Well, in the original equation, no. The whole point is to balance it, and that's why we have to put the 2 right here to balance those nitrogens. So in our final equation, the nitrogens are balanced. That's the whole point, is we're balancing it, but we're just given this. Now, let's look at shortcut method.
Is it harder?
No, it's easier. That's why it's called
If it's a
shortcut.
shortcut, it'd be easier.
Okay?
I'm so sorry.
Help me, Lord, help me, Lord. 1 more 9 weeks. Come on. Here we go.
Is
I'm
that-
not gonna say it. I'm not gonna say it.
All right, so we figured this out already. So we did this part. Now the first thing that I'm going to do in my shortcut, okay, I'm given this, I've got my oxidation states of 0, plus 4, plus 5, and plus 1. I've done that out. But I do need to balance my nitrogens, my non-hydrogens and oxygens. So I'm going to go ahead and put a 2 here, which means that on this one here, I'm going from a plus 10 to a plus 2, right? Which, am I gaining or losing?
You're losing.
Gaining.
Gaining electrons. Sorry.
Because you're gaining
Gaining
negatives,
negatives.
making.
Okay, so how many am I gaining? I'm gaining
Oh.
8 electrons. Because I'm going from plus 10 to plus 2 for the nitrogens. Once they're balanced, you got to make sure they're balanced, so the total. Now the sulfur, they're balanced, so I'm losing
4.
4 electrons. Okay? So now I know I'm losing 4, gaining 8. So I got to multiply this by 2 to make electrons gained equals electrons lost. So I'm just going to put a 2 here and a 2 there. Okay? Now I just have to balance my hydrogens and oxygens with waters. So I have 6 oxygens, 6 oxygens, and 1 oxygen. So I have 6 and 6, so I need 1 water over here. Okay, you don't need the 1. I need a water. Now my oxygens, I have 1 oxygen and I have 6. I have 7 oxygens. I have 6, I have 7 oxygens. Oh, I need 2 hydrogens, pardon me. 2 hydrogens, 4 hydrogens, 4 hydrogens. I'm good. It's balanced.
Can you just do it like that?
On multiple choice, that's the way you're going to want to do it. Okay? Let's go back and let's look at one other one. I don't want to change the page, so somebody read off 26A. Cr2O7, 2 minus, plus what?
NO2 minus.
NO2 minus went to Cr3 plus NO3 minus.
Yes, sir.
Wait, did we just use it?
Yeah, but
This
this
is-
shows the short.
We're gonna just do the shortcut, okay? So again, I learned that this is plus 6 going to plus 3, and we determined that this one was plus 3 going to plus 5. Okay, I really should do it in a different color. Okay, plus 6, plus 3, 3 plus, and plus 5. Okay? So now, I balance this with a 2, because I know I got to get my 2 chromiums. So this is really, I am going from plus 12 to plus 6.
Wait. You're gaining 6.
There, 6 negatives, because I'm adding minus 6. Okay, so I'm gaining 6 electrons. NO2 to NO3 here. Okay, I am what?
Or no, sorry, losing 3. No.
Losing 2.
Oh, that's what we tripping on.
Losing 2 electrons. Okay, so what do I have to do? Multiply
By 3.
this one by 3. Okay, so I'm going to have 3 and 3. I'm going times 3. Okay,
Wait, what?
Because you have 6 on the
because
top.
I got gaining 6, I'm
Oh.
losing 2. Got to make electrons gained equals electrons lost.
How's it going?
Okay, so now all I do is balance my oxygens and hydrogens. So I do oxygens first. I have 7 and 6 makes 13. I have 9. So what do I need?
4.
4 waters. That gives me 8 hydrogens,
Plus
but 8 H pluses. And it's balanced.
8. If it says we have to write out the.
Well, I'm going to show you in the practice problems, you'll see with the half reactions, these are almost always in a multiple choice, okay? To where you would just have to kind of do that in a multiple choice. That's why the shortcut method is real easy in a multiple choice. I want you to be able to see both. But it's just, all this is doing is making sure electrons gained equals electrons lost. We're balancing charge, okay? Then we balance atoms with H plus and H2Os. Okay? That's balancing. But now what we want to do, shoot, how much, we go to 5 after, right?
Mr. 12.
And my clock is about 4 or 5 minutes slow.
11:55 right now.
5, so I got 10 minutes, okay.
But we have 3 up.
Yes.
Because so many people are not.
Okay.
Okay?
Stay gone, guys.
Oh, you're getting a call, by the way.
We should answer.
Am I really?
Yeah, you're getting a call.
Oh,
Yeah. Ask. Yeah, answer.
local strip club.
It might be the refrigerator guy.
good, probably.
The strip club?
Hello?